Dear all, welcome back. Let us continue with the second part of the variable length coding. We'll take the same example determine the code word for an efficiency using the variable length code for a given message set whatever we are seeing for the Shannon phenomena. And the given probabilities are 1 by 16, 1 by 8, 1 by 4, 1 by 16 and 1 by 2. Let us start with the Huffman coding. First let us see the procedure for making the Huffman code. First step is rearrange the probabilities in the descending order. Then assign 0 and 1 to the least two simple probabilities. And the third step, sum up the two probabilities, that is the least two probabilities, and move to the topmost position. Step 4, start coding by backward tracing. Let us see the procedure with the same example. Step 4, start the coding by backward tracing, repeating the first three steps until the completion. Let us see the coding for the given example. For the given example, M1 has got probability of 1 by 16, M2 1 by 8, M3 1 by 4, M4 1 by 16 and M5 1 by 2. Let us rearrange in the decreasing order. So the rearranged probability, we know that 1 by 2 is the maximum. So M5 comes first, M3 1 by 4, M2 1 by 8, M1 and M4 1 by 16 each. Now the first step is assign 0 and 1 for the last two. Now let us move this to the add up. When you are adding 1 by 16 and 1 by 8, we will get it as 1 by 8. 1 by 8 is here. So let step 1, let us consider like this. Trace the same 1 by 2, 1 by 4 and this is 1 by 8. But addition of 1 by 16 and 1 by 16 it is again 1 by 8. So let us move this to here. So this is 1 by 8. This one can be traced down. So that is 1 by 8. For the next step again assign 0 and 1 for the probabilities of the last two. Sum up these both. When you sum up 1 by 8 and 1 by 8, how much we get? It is 1 by 4 again. So 1 by 2 is higher than that. So let us keep it 1 by 2 as such. 1 by 4 is a combination of these both. Let us move to the top. So it will be 1 by 4 and this 1 by 4 will be moving down. This will become 1 by 4. Again 1 by 4 and 1 by 4 least ones. So as it 0 and 1. Now 1 by 4 and 1 by 4 added to give 1 by 2. So move this to the top. This becomes the step 3. Step 2, step 3. So this becomes 1 by 2 and this 1 by 2 we can just move downward. Now the last step again it is 0 and 1. So assigning this will be over. Let us see how we are coding it. Coding is done by backward tracing. Okay, first trace it forward and write the codes in the backward direction. So let us see this. So for the M5, let us trace where it goes. Steps here, move here, then towards this. So this is the first case. For the second, okay, let us write the code for the M5. First code, I will write the code here. Trace it from the back. So here it is 1. Okay. So the code is written opposite directions. Okay. So first one is 1. We are tracing back. So it will be only 1. For the second one, let us see from the M3. So move from here. It goes to the next. Now it is 0. Again from here it is moving towards this one. So it is 0. This one it is 1. So it will be 0, 1. Backward tracing. This 0 comes first and this 1 second. 0, 1. And for the third one, it starts from here. Trace it here. So it is again where it does go from this point. It goes towards this 4. Again it is 0. Again it is moving from here to here. So the code traces backward will be this end. So 0. Coming here next level 0 and the next will be only 1. For M1 that is 1 by 16. So we'll start from here. It goes here going towards this, then 0. Again coming here. Again it goes here. Continue like this. So what is our code? Backward tracing. So trace it from here. 0. it goes to the next level as 0, and here again it comes to this 0, and again it is a 0. And the last one here starts from here, it goes like this. Again same trace you can take. Till here it is the same, because your 1 by 16 and 1 by 16 follows the same path, only difference is at the last one. So 0, 0, 0, that is this 0, this 0, this 0, and this one will be the 1. This is the codes for each of this. So let us see the efficiency, code word length as well as the symbol. Let us see the messages. We'll write like this: M1, M2, M3, M4, M5. Now codes separately we'll write it, rearranging. What is the code for M1? M1 is all zeros. M2, what is for M2? The third one, 0, 0, 1. M3, second one, that is 0, 1. M4, again it is 3, 0, 1. And M5, the last one. Okay, this is our code words. So as what we are seeing for the Shannon-Fanon coding, we will just see the code word length, entropy and its efficiency. Let us find out. What are the formulas? The code word length for M1 it is 4, M2 3, M3 2, M4 again it is 4, and M5 it is the 1. So it indicates that it is a variable length code. Let us see the efficiency. In order to find the efficiency, as usual, as in Shannon-Fanon code, we have seen that formula: efficiency will be equal to h bar divided by L bar into log 2m, where m represents the number of bits. So if it is a binary bit, you can say that it will be having 2 digits, 0 and 1. If it is a ternary, it will be 0, 1, 2, 3, 0, 1, 2, and for quaternary, it will be 0, 1, 2, 3. So this you can consider depending upon our examples. So let us find out what will be the average code word length. So L bar will be equal to summation k equal to 1 to m pk lk. Already we know that how much is our things. Pk will be equal to 1 by 16 43241. Probability into the length of the code. 4 plus 4. This is for M1. M2. What is the probability? 1 by 8 into code word is 3 plus M3, it will be 1 by 4. The code word length will be 2 plus M4, again it is 1 by 16 into 4 plus M5, it will be equal to 1 by 2 into 1. Let us try to calculate the probable average code word length, L bar. So our average code word length L bar will be equal to 1.875. Now let us calculate the entropy, that is H bar. So H bar, as usual, we know that it will be the summation of Pk log of 1 by Pk. So this already we have done it in the Shannon-Fanon coding. It is same. So same probability and same message. So our entropy will be equal to H bar will be again calculated as such. And last time we had just calculated it is, again it is 1.875. And the efficiency, as usual, what is the formula for efficiency? It will be equal to H bar divided by L bar log 2m. So again m will be equal to 0 and 1 only we are using. So it is only 2. So log 2 will be equal to 1. And so your efficiency will be equal to H bar 1.875 and our L bar will be equal to 1.875. So this is again it will be equal to 100%. So okay, so we have seen that this also has got 100% efficiency. Last time we have seen that our Shannon-Fanon coding, though it has got the same code word length, it has got a variable code. This is also has got a variable code. Both the codes are different. but the percentage efficiency of this particular problem is 100% for both the cases. That's it for today. See you in the next.